I'm Anil Kumar. We are looking into examples of geometric distribution. The question here is, consider a repeated rolling of a pair of fair die. What is the probability that the first roll of double occurs in fourth roll? And the second part is, what is the expected waiting time or number of rolls before a double is rolled? So these are the two questions which we need to do. Now, since there is a waiting time, we'll look into the probability distribution formulas for waiting time. Okay, that is kind of important to understand. The difference is that the expected value when the waiting time is involved is Q over P, right? So when we are doing normal geometric distribution, then the expected time is 1 over P, where the number of trials is the total number of trials. Now waiting time, we take n minus 1 as the waiting trials, right? So that is what the difference is. Okay, let's get back to the question. Consider a repeated rolling of a pair of fair dice. What is the probability that the first roll of double occurs in the fourth roll? Now when we say double, that means we are looking for combinations of 1 1, 2 2, 3 3, 4 4, 5 5 and 6 6, right? So these are 6 combinations out of 36, correct? So these are 6 combinations out of 36, and we say success in our case is to, so random variable which defines the success is to roll a double, right? Is to roll a double. Now probability for success in our case will be 6 out of 36, which is 1 out of 6. So if the probability of success is 1 over 6, probability of failure will be 5 out of 6, correct? 1 minus 1 out of 6. Okay. Now it says, what is the probability that the first roll of double occurs in the fourth row? That is to say, fourth roll. So that means first 3 rolls as failures, right? So we have kind of failure, 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 and then success. Do you see? That is the case. So when we are saying, what is the probability that the first roll of double occurs on the fourth roll? That means the first 3 rolls are failures, and on the fourth one we get a success. So the probability for this is, since these are independent events, is sum of all this, product of all this, correct? So probability for probability for failure, 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 and then success is, for failure it is 5 over 6. So it is 5 over 6, that is 3 times Q, times success, which is 1 over 6. Right? So that gives you the total probability in this particular case. So it is 5 divided by 6 cube times 1 divided by 6, which is equals to, in decimals, 0.0964, right? So that is the probability that the first roll of double occurs on the fourth roll. So that is how you could do part A of this question, correct? Now let's look into the second part. It says, what is the expected waiting time before a double is rolled? That means that is the waiting time, right? So like 3 failures were waiting time in the first case. So we got success on the fourth trial. Now when we are doing the waiting time, then the expected time is Q over P. In our case, Q is 5 over 6 divided by 1 over 6, and that is equals to 5, right? So the waiting time is 5 rolls. So the answer is expected waiting time is 5 rolls, right? So the sixth will be a success, correct? So that is what it is. And even from the definition, when we say probability of success is 1 out of 6, that means if you make 6 rolls, there will be 1 success. We're just saying that 5 rolls could be failures and then a sure success, kind of. That is what is expected, right? So that is how you could do such questions. I hope you understand the concept. I'm Anil Kumar. You can always share and subscribe my videos. Thank you and all the best.